Hi all, welcome you all to my YouTube channel. From this video, I would like to talk about one of my research publications predicting winning percentage of limited overs cricket using Pythagorean formula. This research was published on Journal of Sports Analytics in 2021. You can see the link to the article on description box. I think you all interested in cricket, so let's look at this research publication. The Pythagorean Winner's formula, which was developed by Bill James in the early 1980s, is a sports analytics formula that can be effectively used to calculate winning percentages for sporting events. This calculation is based on the average number of runs scored and the average number of runs allowed by a team. So here you can see that the Pythagorean Winner's formula, that is, winning percentage equals Rs to the power gamma divided by the total of Rs to the power gamma and the Ra to the power gamma. Here, Rs means runs scored, Ra means runs allowed. The gamma is the Pythagorean exponent. One can directly predict the expected number of matches a team will win in a future series based on the observed winning percentage for the period so far. For example, the observed winning percentage of the matches played from the end of the last ODI Cricket World Cup to the beginning of the next World Cup can be used to predict the number of matches expected to be won by a team in the next World Cup. One can do a better prediction using the Pythagorean winning percentage. The added value of the Pythagorean winning percentage over the regular winning percentage is that it takes into account more accurate defensive and offensive strengths of the teams by using the actual runs scored and actual runs allowed. The regular winning percentage does not have a way to accommodate the actual scores and it uses the binary outcome of a game, which is the win or loss. However, with the appropriate Pythagorean exponent, that would be gamma, the Pythagorean winning percentage utilizes additional information of the actual scores, which in turn provides predictions that are more practical. Initially, this formula was used by baseball statistician and Pythagorean exponent was assumed to be 2 in the baseball. There are several studies for the several sports using the Pythagorean formula. However, application of the Pythagorean formula to cricket has been more limited. In 2016, Winnie used the Pythagorean formula to estimate the winning percentage of the 2020 Cricket Big Bash League, an Australian domestic competition. He has further shown that the appropriate gamma for the 2020 Cricket Big Bash League, which was 7.41. Also, he suggested that for the cases where the second batting team wins the match without using all the allocated resources, the dependency issue between runs scored and runs allowed could be eliminated by extrapolating the second team's runs total by using the Duckworth-Lewis resources table. It is obvious that, as in any other sport, there could be a significant difference in the performance parameters between international level games and regional level games, such as Big Bash League. Here, our effort is to extend Winnie's results to international limited over cricket. Specifically, the objective is to calculate the winning percentage of the top 10 teams of the International Cricket Council. In particular, the goal is to estimate the appropriate Pythagorean exponent for both of the limited over cricket format 2020 and One Day International ODI. cricket is one of the most popular games in the world, especially among Commonwealth countries. The three main types of cricket matches are Test cricket, One Day International, is ODI and 2020. The two formats, ODI and 2020 cricket matches, have a limited number of overs and are known as limited overs cricket. An over consists of 6 deliveries from bowler to batsman. An innings in ODI and 2020 consists of 50 overs and 20 overs respectively. For all major cricket formats, a team consists of 11 players and the match starts with a coin toss to determine the first batting team. The team's goal is to score the maximum number of runs by using the available resources. The second batting team then attempts to score at least one more run than the first team's total. If they succeed, the second batting team wins the match, but if they fail, the first batting team wins. In 1998, Duckworth and Lewis introduced a way of revising targets for games that are shortened due to weather interruption. This is the current method used by the ICC to revise the target for weather-interrupted cricket matches. It is based on the idea that the batting team has two resources. One is a certain number of overs to face and second one is a limited number of wickets in hand. Based on a mathematical model, the Duckworth-Lewis method provides a table with the remaining percentage resources at any given stage of a game. For example, at the beginning, a team with all the wickets and all the overs remaining has 100% of the resources. If it rains and the game is delayed by several overs, then the team does not get the 100% resource available to that team. The Duckworth-Lewis method is used to calculate the revised target based on the remaining percentage of resources after the interruption is over. Complete details of the method can be found in Duckworth and Lewis in 1998, which provides a two-way table for the available number of overs and the number of wickets lost to ease calculations. In particular, this study, if the second batting team wins the match with wickets and overs are still remaining, their total will be extrapolated using the Duckworth-Lewis resources table as suggested by Winnie in 2016. In cricket, when the second batting team surpasses the target score set by the first batting team, the game ends and the second team is declared as the winner. However, had the second team been given the opportunity, it would have continued to score while using the remaining amount of resources allocated to it. When the game ends this way, using the second team's actual scores as the runs scored distorts the true offensive strength of the second team. Therefore, it would be more appropriate to adjust the score incorporating the unused amount of resources as well. This can be done using the Duckworth-Lewis method. In particular, the second team's score can be extrapolated as if it was allowed to consume 100% of available resources. Let's discuss about the methodology Here we have used the Pythagorean formula to cricket, following the procedure of the Miller in 2006 under assumptions that runs scored and runs allowed follow independently distributed Weibull distributions with a common shape parameter, the probability density function of Weibull distribution. You can see here gamma is the shape parameter, alpha is the scale parameter and beta is the location parameter. So as explained by Miller in 2006, the number of runs scored and the number of runs allowed in a given match follow independent Weibull distributions with parameters alpha runs scored, the beta gamma and alpha runs allowed beta gamma respectively, by denoting the mean of runs scored as Rs and mean of runs allowed as RA for a given team. So let's discuss about the probability formulas they have used. So before moving to the probability formulas, so I want to discuss about which data we have used for this study. So we have used data from ODI matches played by the top 10 national teams of the International Cricket Council during the time period between the 2015 and 2019 ICC World Cups. These teams are Afghanistan, Australia, Bangladesh, England, India, New Zealand, Pakistan, Sri Lanka, South Africa and West Indies. For 2020 cricket, in order to have sufficient data, we use data for all matches played by the above 10 teams between 2012 and 2018. Here you can see the probability of runs scored greater than runs allowed given this formula. So therefore we can calculate the winning percentage of the team is using this formula. Winning percentage equals RS minus beta to the power gamma divided by the total of RS minus beta to the power gamma plus RA minus beta to the power gamma. Here we use both the maximum likelihood method and the least squares method for parameter estimation. So let's discuss about the parameter estimation next. So when we discuss about the parameter estimation, here we have used the similar procedure as Dini in 2016 used. The runs of 2020 matches were split into means to estimate the parameter of the viable distributions, as you can see here for the 2020 cricket matches and the ODI cricket matches. The same binning structures were used for each team with the both least squares method and the maximum likelihood method. The translation parameter based on this here, we have used the beta was fixed as constant -0.5 priority to the parameter estimation. This translation parameter was included to overcome the issues that arise due to the discreteness of the data in the continuous viable model. The model parameters alpha runs scored, alpha runs allowed, gamma were estimated using the both least squares method and the maximum likelihood method for each team. Subsequently, winning percentages also calculated using that above formula. The winning percentages equals RS minus beta to the power gamma divided by the total of the RS minus beta to the gamma and the RA minus beta to the gamma. Thereafter, the predicted number of wins was calculated based on the estimated winning percentages for each team. In this table, you can see that the gamma values for ODI matches for each of the 10 teams we considered using the least squares method. The average of the exponent gamma using the least squares method was 5.4 and the standard deviation was 1.3. This table, so you can see that the gamma values for the ODI matches for each of the 10 teams using the maximum likelihood method, the mean and the standard deviation of the maximum likelihood estimates of gamma were 4.84 and 0.56 respectively. In this table, you can see that the results from the least squares method for 2020 cricket matches. The mean and the standard deviation of gamma using the least squares method were 6.49 and 1.42 respectively. The highest predicted winning percentage was attained by England team using both the maximum likelihood method and the least squares method for the ODI. So this was again not surprising at all as England won the 2019 World Cup. Afghanistan played considerably fewer number of matches than the other 9 teams. Therefore, we excluded their results when we calculating the descriptive statistics of gamma. The later I will discuss about those. However, this exclusion did not cause any significant difference in the numbers. In summary, for both ODI and 2020 matches, we observed that the least squares estimates of the gamma were slightly higher than the maximum likelihood method. So let's move on to discuss about the goodness of fit of the Weibull distribution and the independence of the random variables runs scored and runs allowed using Kendall's tau test. Here, so this table shows the results from the maximum likelihood method for 2020 cricket matches. So for the maximum likelihood method, the values for the mean and standard deviation were 6.05 and 0.91 respectively. The chi-squared goodness of fit test was used to evaluate the appropriateness of the Weibull distribution for modeling the runs scored and runs allowed for each team separately. The estimates of alpha runs scored, alpha runs allowed and gamma using both the maximum likelihood method and the least squares method were used as parameter estimates to perform the chi-squared goodness of fit test. So here we have used the hypothesis as the null hypothesis as the data of cricket match is consistent with the Weibull distribution, and alternative hypothesis H1 as the data of the cricket matches is not consistent with the Weibull distribution. So this table shows the results for goodness of fit test using maximum likelihood method for ODI cricket matches. So here you can see that all the p-values are above 0.05, which indicates that the use of Weibull distribution for runs scored and runs allowed is appropriate for ODI data. Shows that the results for goodness of fit test using maximum likelihood method for 2020 cricket matches. So here we can see that the 2020 data and the results are consistent as the ODI data. So that means the use of Weibull distribution for runs scored and runs allowed is appropriate for 2020 data as well. Actually, we have investigated the goodness of fit of Weibull distribution using least squares method as well. So, however, the results were closely similar to those obtained using maximum likelihood method. Therefore, tables showing the least squares results are not included here. From figure 1 to figure 4 show some representative plots to describe the appropriateness of the Weibull fit for the observed data. Here I have not included all the plots, but you can refer the plots in the published article. So you can see the link given in the description box. discuss about the independence of runs scored and runs allowed. Kendall's tau test was applied to test the statistical independence of runs scored and runs allowed for both ODI and 2020 formats. This test is a non-parametric method to test the statistical independence of two random variables. A Kendall's tau value closer to 0 is an indication of the independence of the two random variables. Here we have test the hypothesis as follows. So we use the null hypothesis as runs scored and runs allowed of cricket matches are independent. The alternative hypothesis as runs scored and runs allowed of cricket matches are not independent. This table shows that the results for Kendall's tau test for ODI cricket matches, as seen in this table, runs scored and runs allowed were statistically independent for all ODI teams except Bangladesh, because the Bangladesh p-value is less than 0.05. This table shows the results for the Kendall's tau test for 2020 cricket matches. It shows that the runs scored and runs allowed were statistically independent for only 4 of the 10 teams, which are Afghanistan, Australia, New Zealand and West Indies. As we see, the independence assumption is valid for the ODI data but not for the 2020 data. One explanation for why the assumption does not hold for the 2020 data while it does for ODI data is the difference in length of the two formats. Usually, when the second batting team bats, it uses the first team's score as the target. This could induce the dependency between the two scores. With the ODI, this dependency vanishes due to the longer playing time. There are a number of overs. It might be the case that the length of the 2020 format does not have enough time to eliminate this dependency. Therefore, the results related to the 2020 data reported herein should be considered in light of limitations of the validity of the assumption of independence. So, in this study, we have shown that how Bill James' Pythagorean formula can be applied to the game of cricket. In particular, we have derived the appropriate exponent gamma for the two limited overs international cricket formats ODI and 2020. The maximum likelihood method has resulted in mean gamma values of 4.71 for ODI matches and 6.06 for 2020 matches. The least squares method resulted in slightly higher values for both formats with mean gamma values 5.01 and 6.56 respectively for ODI and 2020. So, given the desirable properties such as consistency, invariance, asymptotic normality and relationship to the sufficient statistics, we suggest that the maximum likelihood estimators are more apposite estimators to be used in practice. In addition to this, the standard deviations of the maximum likelihood estimates of the gamma were lower than that of the least squares estimates for both ODI and 2020 formats. This includes that the suitable gamma values are 4.71 and 6.06 for ODI and 2020 respectively. The only comparison that can be found in the literature is the gamma value is 7.41, which was given by Dini in 2016. for the 2020 Cricket Big Bash League and Australian domestic competition. So, as we mentioned in the methodology, we have used the data from the matches played during the time period between 2015 and 2019 Cricket World Cup with the derivation of the gamma for ODI matches. Consequently, we used those estimates to predict the number of matches expected to be won by each team in 2019 World Cup. As a comparison, we have also used the regular observed winning percentages for the given time period to predict the expected win totals, the number of matches for the World Cup matches. Based on our analysis, England had the highest Pythagorean winning percentages as 0.76 of the 2019 World Cup, and we would have predicted them to win the tournament, which they did. Based on our findings, the Pythagorean formula would have predicted the 2019 World Cup semi-finalists to be England, India, South Africa and New Zealand. Of these, only South Africa failed to make the semi-finals, with Australia qualifying instead. We have also quantified the predictive powers of the Pythagorean winning percentage and the regular observed winning percentage by using the actual win totals and implied win totals for 2019 World Cup outcome. The resulting outcome for regular observed winning percentage was 5.10, and for the Pythagorean winning percentage it was 4.71. The lower value for the Pythagorean winning percentage indicates that the prediction based on the Pythagorean expectation is closer to the actual outcome. However, the significance of the improvement should be justified by using a statistical test and the left as a future study. This demonstrates the effectiveness of the Pythagorean formula in predicting cricket outcomes. It performs better than the prediction based on the regular observed winning percentage. As cricket continues to grow in popularity, this formula may be used as a prediction tool in the sports betting industry as well. So I hope you have enjoyed this video. So don't forget to subscribe and hit a like to my video if you're interested. So please click the bell icon to know about my upcoming videos. Thank you. Don't forget to share this video with others.